here we have an example graph to finish off this piece. This graph has 5 sections, or 6 sections, sorry. What I'd like you to do first is pause the video here and write down in your notes what you think is occurring in each section. Then press play again and I will go through it. Okay, for this one, section 1, we're moving away from the origin in the positive direction at a constant velocity. For section 2, you're still moving away from the origin in a positive direction, but you're decreasing velocity or slowing down. In 3, you're moving at a constant speed of 0, constant velocity of 0, so not moving, staying at the same position. In section 4, you're moving in the negative direction at a constant velocity. You go past the origin, this point here, and keep going. So it's just like walking back past where you started in the opposite direction at a constant velocity. 5, you're stopped, constant velocity of 0. And then 6, you're speeding up, but in the positive direction, headed back towards the origin. Now there's a couple of things I would point out here. You notice these 2 hard angles. In reality, hard angles cannot exist because you could not go from stop to moving at a constant velocity without speeding up first. So in reality, this would have a little curve to it. Same thing here, this would have a little curve to it. But to simplify this and not add more steps in, sometimes we'll draw it with these distinct transitions. Now what I want us to be able to do is to take that previous graph and draw the v versus t that corresponds. So take and draw our axes, go back and look at the previous graph. What I would do here, pause and rewind the video, look at the previous graph, draw your v versus t, then hit play. You can fast forward back to this point and listen to the explanation and see if you got it right. Okay, so for our v versus t, we're going to flip back to sections. So section 1, we're moving at constant positive velocity. I don't have values on that graph, so I'm not going to figure out an exact value. But so section 1 will be a constant velocity. If I had values, I could figure out the exact slope. Section 2, I've got a decreasing velocity to 0, still in the positive direction. So now it's going to decrease to 0. What I'm looking for from you in these graphs is to be able to draw the shapes. We're not going to do a lot with translating exact values, but we are going to need to be able to draw the shapes. Section 3 is stopped. So we're going to stay right here along the axis with a velocity of 0. Section 4 is moving with a constant negative velocity. And you'll notice I dropped straight down here because there wasn't a change in velocity. It wasn't a curved section before that. And that's how you get these straight lines, which say 0 time, but changing velocity. Section 5, we're stopped again, so I'm going to have to jump back up to my axis. And section 6, I'm speeding up in the positive direction. So that is what the velocity versus time graph would look like in this case. So what we want to be able to accomplish out of these is to be able to look at these graphs of position versus time and draw the corresponding shapes of the velocity versus time.